video, we're going to look at proportional relationships. We're going to talk about proportional graphs. Did that a little bit in 7th grade. Remember, a proportional graph is a graph that goes through the origin. So that means that the y-intercept is 0. So we talk about slope-intercept form. We say y equals mx plus b, with b being our y-intercept. So in this case, we're just going to have y equals mx, since b is 0. Okay, we've talked about slope. We've talked about rate of change. Now we're going to throw in another word here, unit rate. It's the same as slope. It's the m and y equals mx plus b. We can find it the same way. We can do rise over run if we have a graph. We can do y2 minus y1 over x2 minus x1, the slope formula, if we have coordinates. This is also called the constant of proportionality. Big word there, if you hear that. It means unit rate, which is slope. We can also divide the y-coordinate divided by the x-coordinate, since the graph is proportional. So this last way is my favorite way to do because it's a whole lot easier. So we'll look at some examples here. First one down here says, find the equation, remember that's y equals mx plus b, that shows the relationship between the number of folders, F, and then total cost, which is C. So if we look here, we have folders 1, 2, 3, 4, 5. So that means if I want to buy one folder, it's this, 2, it's this, 3, it's this, so on and so forth. So the cost is down here. Okay, well, the easiest thing to do always, if they give me 1, that is my unit rate, right? Because unit rate is per 1. And so since unit rate is slope, then this part right here gives me my slope. Okay, so all I have to do is say y equals, but in this case, we're not going to use x and y, we're going to use f and c. Okay, so we could say c for cost equals 0.50f. That would be our equation. That means that our cost is equal to 50 cents per folder, is kind of what that means. Okay, so for every folder I buy, I'm going to multiply that by 0.5. Okay, so how could I find the rate of change or the unit rate there if I didn't have 1 as an x value? Okay, well, let's look at the next example. It says, which type of peppers are less expensive and how much less per pound are they? Okay, so we have green peppers. That's represented by the equation y equals 2.5x, where y is the cost and x is pounds. Then we have a table for red peppers. It says red peppers, here's pounds, and here's cost. Okay, what I always like to do is write them both in an equation, because then it's real easy to see the unit rate, because that's right there, 2.5. So I know for green peppers, each pepper, or well, I should say each pound of green peppers is $2.50. That's what that means. So down here, I don't know how much each pound is, but I do know 2 pounds, 4 pounds, 6, 8, and 10. So remember up here, we could say we divide the y-coordinate by the x-coordinate. Okay, so a lot of times we'll always have cost. Okay, so usually about 99% of the time when we're dividing, cost will always be in our numerator. Okay, so let's take a look here. Let's just use our first coordinate they gave us. Okay, so we have x and y. This would be pounds. So the coordinate would be 2, 4.5. Okay, so I'm going to divide 4.5 divided by 2. Okay, well, if I think about that, okay, I could do that right here. 4.50 divided by 2. Okay, well, that'll go in twice. So now I get 4. Bring up my decimal. 2 will go into 5 also twice. That gives me 4. Bring down my 0. Now I get 2.25. Okay, so now the equation here for red peppers would be y equals 2.25x. Okay, now I can answer my question. Which type of peppers are less expensive? Well, if you look here, green peppers, $2.50 per pound. Red peppers, $2.25. So which ones are less expensive? Red peppers by, because it says how much less per pound. Well, if green peppers are $2.50 and red peppers are $2.25, then red peppers are less or least expensive by, we could say 25 cents per pound, or we could say, or we could write it like this, 25 cents per pound. And that would be our answer. So red peppers are less expensive, and they are 25 cents cheaper per pound. Okay, so we got a couple other examples to look at. All right, so let's look at our first one here. It says, current gas prices can be represented by the equation y equals 2.34x, where y is the total price and x is the gallons of gas. Okay, and we have 4 questions over here that we're going to answer. The first one says, which coordinates would represent 16 gallons of gas? Okay, well, we got to think about it here. Gallons of gas is x or y? Well, it's x. So all I need to do is plug in 16 for x and see if, or not see if, but see what my cost would be, and that's going to be my coordinate. Okay, so for this one, if I plug it in and I do 2.34 times 16, 6 times 4, 24, bring that 2 up here. 6 times 3 is 18, plus 2 is 20. Carry my 2 up here. 6 times 2 is 12, plus 2, 14, placeholder 0. 1 times 4, 4. 1 times 3, 3. 1 times 2, 2. So now I add those up. I'll write that up here. 4 plus 0, 4. Once again, 0 plus 4, 4. 4 plus 3, 7. And 2 plus 1, or 1 plus 2, which is 3. I had 2 decimal places, so 1, 2. So I get 37.44. So really what that means is that if I'm going to buy 16 gallons of gas, it's going to cost me $37.44. The question asked me, how do I write that as a coordinate? Well, what was x? X was 16. So I go 16, comma, and y was 37.44. That's my coordinate. Okay, number 2. It says, will the graph go through these coordinates? 9.36, 4, and 11.75. Well, if I take a look at that, this is my x coordinate, right? So that means if I plug that in for x, I'm going to get 4. Well, I know it's decimals here, but that's like 2 times 9. Well, that's 18, right? So we know that's going to be a lot greater than 4. Well, let's check this one. 2 times 11, that's 22. Okay, so what do you think they did here? Well, it looks to me like they flip-flopped my coordinates, right? Because if I plug in 4 for x, I will get 9.36. Okay, so they flip-flopped. So if this point said 4, 9.36, that would be on my graph. But it's backwards. So we would say, no, those are not going to be on my graph. Okay, number 3 says, what does the slope represent? Well, where is my slope? Okay, slope is right there, right? 2.34. Well, that means my slope that each gallon of gas is $2.34. So I could say it's $2.34 per gallon. Okay, now it says, what would the slope be if gas prices increased by 15 cents? Well, what's the slope right now? 2.34. So all I have to do is if I add 15 cents to that, 4 plus 5 is 9, 3 plus 1 is 4, bring down my 2, so I get 2.49. So my new slope would be 2.49. So my equation would say y equals 2.49x. So that's what my new slope would be in my new equation if the gas prices increased by 15 cents. All right, last example we're going to look at. It says a beef jerky store sells jerky by the pound. The cost for X pounds of teriyaki jerky can be represented by the equation y equals 6.25x. So I know that's going to be important. Where y is the total cost for X number of pounds. The cost for 6 pounds of habanero jerky is $30. Once again, that will be important. Okay. So number 1 says they want us to graph both proportional relationships, and number 2 says which jerky has the lower unit price. Okay, well, let's look here. Let's graph teriyaki. Let's graph teriyaki in blue and habanero in red. Since habanero is hot, we'll do that in red. So I'll leave the red pen there for a second. Let's get the blue out. And we're going to graph this equation, y equals 6.25x. Well, if I look here, whenever x is 1, and x would be amount in pounds, then y is 6.25. Okay, that's going to be pretty hard to graph because I go up by 5s here. So what can I do to make this graph easier? Well, let's look and see how many pounds I'm going to have until I get a number that would fit on here. Okay, well, 2 pounds I know is going to be $12.50. Well, that's going to be tough to put on there as well. 3 pounds would be $12.50 plus 6.25. Okay, so we're going to get $18.75. Once again, tough to get on there. Okay, well, if I do 4 pounds, let's think about that. If I did 4 pounds, that'd be $18.75 plus 6.25. That's going to give me an even $25. So that's going to be perfect. So the point that I want to plot is the point 425. Okay, so now I look here, I go 4, I need to go up to 25. So do this best I can without a grid. Let's say it goes right there. Okay, so I just need that 1 point right there. I can take my ruler, start it at the origin. Why can I start at the origin? Because if I don't buy any beef jerky, does it cost me any money? No, that's why it's proportional. Okay, I take my line, I draw it just like that. And that would be for my teriyaki jerky. Okay, now let's graph habanero. All right, well, they tell us that the cost for 6 pounds is $30. So they didn't give us an equation, but we do know that for 6 pounds, it's going to be $30. Okay, so we can graph that point. So that point would be 6, comma 30. So let's do that. 6. Let's go up here to 30. Just try and get the best we can. Let's see, about right there. Okay, so now let's take our ruler again, going through the origin once again. And once we graph this line, it should be real easy for us to see which one is going to cost more. Okay, so looky there. All right, we've got habanero in the red, and we've got teriyaki in the blue. Okay, so we're looking there, and just based off of that, just based off the graph, we're going to be able to see which one costs more. Okay, the one that costs more is going to have the bigger slope or the greater slope. Okay, so if we look here, habanero is in the blue, or excuse me, teriyaki's in the blue, habanero's in the red. So just based off that, which one do you think is going to have, or which one do you think is going to have the higher unit price? Probably teriyaki, because it's a little greater slope. Okay, so what's a good way for us to compare? Well, like I said, I like to write it in the equation. So let's take 6 pounds of habanero jerky for $30 and write that as an equation. Well, if I look here, when I had 1 pound, it looked like it was going pretty close to 5. But how could I check that? Well, if I go back to my first page, I remember that if I divide y divided by x, or cost divided by pounds, I'll get my unit rate. So 30 divided by 6 would be 5. So I know that teriyaki was y equals 6.25x. Well, for habanero, it's going to be y equals 5x, right? Because 30 divided by 6 is 5. So if I write my teriyaki equation, y equals 6.25x. Okay, now I can see which one's going to have the lower unit price. Lower unit price is going to be habanero. By how much? $1.25 per pound. Okay, and that's pretty much all we do with proportional graphs.